So what we need to do right now is do a little practice problems, a little extra help. Maybe you could take a look at some of the things that we are doing here in Chapter 4, okay? Unit 4, Chapter 4, which deals with kind of atoms and the makeup, atomic structure. So certainly something we need to recognize is how many protons, electrons, neutrons. So again, I could just determine, let's do bromine here. Bromine with a 35 here, let's say 80 and 1 minus. And certainly one of the questions that we could ask is how many protons, electrons, and neutrons in this chemical symbol. To me, the key is the protons. You need to know how many protons. Why? Because the protons is one that tells you what it is. Or if you know what it is, it tells you how many protons. And so in this lower left corner is our atomic number, which is our number of protons. So we would have 35 protons in this one, okay? Now, in order to determine the electrons, we look at the charge, okay? So this is an ion, all right? If there is no charge, simply there's nothing written in the upper right, then the protons equal the electrons, because protons are positively charged, electrons are negatively charged, and therefore they'd be the same if it's a neutral atom with no charge. This is an ion, and there's a charge, which means it has a 1 minus, which means 1 minus, that means there's more electrons than protons, because protons are positively charged, electrons are negatively charged. If you get a 1 minus, you get more negatives. So therefore, there would be 36 electrons in this example. Our last thing that we're looking for here is our neutrons. And this number up on top, not a great one here. Let's, let's get out of this. Quit that. Let's change this color here, I'm sorry. Let's go to yellow, I think that'll be good. So 80 right here. That is the mass number, and the mass number is the protons and neutrons added up together. So if you have 80 and you know you have 35 protons, since it's protons and neutrons added up, we would have 45 neutrons in this example. Okay, so there's one example. If I now move to another one and I give you the protons, electrons, and neutrons and ask for the chemical symbol, so complete chemical symbol, and I give you the protons, electrons, neutrons, let's, I don't know, how about 20, 18, 22, all right, and I ask for the complete chemical symbol. The first key is again the protons, number 20, so therefore we look it up, calcium. Calcium's number 20, so it's the atomic number, therefore 20 is the number of protons. The electrons, well, if we have 20 pluses, because that's what the charge is, a positive charge, electrons have a negative charge, the net charge is a 2 plus. So we have a 2 plus charge on it. And lastly, the neutrons and the protons get added together, 42, to give you your mass number. So there would be the complete chemical symbol for this one with the 20 protons, 18 electrons, and 22 neutrons. Okay. Moving on here for another example in Chapter 4, dealing with alpha and beta decay. So again, with the alpha and beta decay, what you need to really remember, so Chapter 4, again, some more alpha, beta decay. What you need to really remember is the symbol for alpha and beta. Well, I've just drawn them, but again, alpha has a 4 and 2, beta 0 minus 1, and of course we have that gamma, which is a wave 0, 0. So these are the real big key here to remembering how to do alpha beta decay. Simply, if there was an example, let's say we said plutonium 242. So So plutonium 242. Now again, and it undergoes alpha decay. And plutonium's number 94. So Pu 94. The 242 tells you the mass number, what isotope it is. And we're going to go through alpha decay. So we break it down immediately. All right. Alpha particle 4 and 2. And then 238, 92. How did I get those numbers? Well, really all we're doing is a little math problem. 2 plus 92. Well, that adds up to 94. Whatever. Same thing on the top. So, number 92, we'll look it up on the periodic table. It is uranium, and I don't forget my gamma wave. All right, so that's an example of a alpha decay. Beta would be the same thing. Let me just say now, let's say I added to this question. Oh, I probably shouldn't have just erased it. Let me quickly do it. Plutonium 242, 94. It goes through an alpha. Here we are again. And so therefore 238, 92 uranium and your gamma. Let's say that it and 2 beta decays. So it continues through more decays. What you could do is simply from that uranium, it now breaks down into a beta particle. 238 stays the same. 93, because of course it's a -1, neptunium, and don't forget your gamma. If it went through 2 beta decays, so there's 1, and here would be your second, 0 minus 1, 238 still, and 94, and notice plutonium again. And yes, this plutonium is different than the original one, because notice, look at your mass numbers. But that would be an example of that. The last thing I want to review real quickly is if we do the average atomic mass from the various isotopes. And so if I say that we have, again, it could be anything. How about if I do like a zinc, this is 30, 64, zinc 65, and zinc 67. Okay, and I said that you had, oh, how about, I guess, let's say we have 5% of this, 80% of this one, and 15% of that isotope. And I want to know what is the average atomic mass of these. Well, what you're doing is you're taking the mass, 64, and multiplying it by the percentage. Okay, taking this mass, 65, multiply by its percentage, and take this mass, multiply by its percentage, and add those three together, which will give us our average atomic mass. So I'm going to go ahead and pull out my calculator here, and 64 times the 0.05, 3.2, 65 times 0.80, 52, and 67 times the 0.15, 10.05. So if we add those all up, you get 65.25, which makes sense that because we have an 80% here, that the average is so much closer to the 65. A little bit more because, of course, 15 versus, let's say, the 5%. So there's a couple of reviews for the Chapter 4 atomic structure types of questions.